Hello students, welcome back to my channel. In today's session, we will be discussing another sorting algorithm, and today's topic is selection sort. So like we have discussed before, sorting is nothing but it is a arrangement of elements in a ordered way. So in the previous session, we had discussed merge sort. Today we will look and see how a selection sort works. So this is a way how a selection sort works. So if we are going to see the step-by-step process, initially what we are going to do is, initially we will start with the first element of a minimum candidate. As in, suppose, as you can see, this is an example. I have 6, 3, 7, 2, 8 and 1. I am supposed to apply selection sort on this, and my output should be in a ascending order, that I should start with the least element and then the highest element should be at the end. So how does this work? So we will do the initially, first we do the scan and we will find out the minimum candidate. Okay, so as you can see here, the minimum candidate is marked with a star. It is nothing but 1. So once we finish that, we are going to iterate and compare. That is, traverse the rest of the array to find the true minimum. So that is what we have done. So initially we have scanned the entire array. Then we have found out the true minimum. Then we are going to perform the swap, exchange the minimum with the element at the current position. As in, so whichever is the minimum, we are going to swap it to the very first position. Okay, now that it is in the very first position, I'm going to assume that the minimum value has reached its correct position. Now I will start the traversal of only this array. That is, as you can see, as a highlighted area. Now I'm going to traverse in this array and find out the minimum. So as I can see that 2 is the minimum, that I'm going to swap into the next position. All right. So next I will only look into the remaining part of the array. Once again, I'll find the minimum and I will swap it to the very first position of the array. So as and when I am inserting the value, I'm going to start the iteration only from here, because it is understood that these positions from wherever I have swapped, I have performed the swap and inserted the element, that is already sorted and it is done. So I need to only now search from the next position. So I will search from the next position and find out the minimum value and swap it. Once again, here as you can see, only these two places are remaining. I will find out the minimum, swap it, and once I complete this, my array is sorted. This is nothing but our selection sort. So why the name selection sort is, we are going to select the minimum value and then we will perform the selection. Okay, when compared to merge sort, this is entirely different concept, wherein in merge sort we were dividing and then merging. Here we are simply iterating to all the values and finding out the minimum and then swapping. So there are two actions which need to be performed. One is we have to search the minimum, and one we need to do the insertion, and then accordingly we need to do the sorting. So that is what is the work what need to be done. Okay, so I hope how the selection sort works is clear. So let us see the algorithm. So as I told you, selection sort has two main part, which is first is the selection sort algorithm itself, and inside that there is another part which is nothing but finding out the minimum value. Okay, so initially I will set the location as 0. Let me take the same example, or simply I will take one example. Let me take 2, 9, 8, 4 and 6. Okay, if this is my array of 5 elements, that is iterate and see. Set LOC is equal to 0. Initially, a variable called as LOC will be 0. Repeat step 3 and 4 for k is equals to 0 to n minus 1. My n value is 5 here. N minus 1 is nothing but 4. Okay. Now, location is equals to I'm going to call a function called as minimum, where I'm going to pass the value k. K is initially 0 and n value is, we have 5 elements. Hence, n value is 5. Number of elements is 5. So this is a minimum function. Now what we are going to do is, first we are going to find out the minimum value among this array. So that is a very simple function what we are going to see. Initially I'm going to set minimum as, once I'm going to iterate and show you. Okay, in the first case, minimum, I'm going to take a variable known called as a minimum, and a of k value. Now initially we have passed 0. So we have passed array 0 and n. Okay, so because we need to first find out the minimum in the entire array. So minimum as of now, I will take it as this value. The very first value, I will consider it as a minimum. And location is the k itself, that is a position itself, which is 0. Now after that, what I'm going to do is, I'm going to take a variable called as j, which will take the next element. Okay, so j is equal to k plus 1. In this case, it is 1. Suppose if I'm numbering this, this will be 0, 1, 2, 3, 4. All right. So j is equals to 1. And I'm going to repeat it. J is equal to 1 to n minus 1. That is nothing but 4. I'm going to repeat it for all these values. So what I'm going to do is I'm going to compare, is there any other element which is lesser than n? Sorry. So I'm going to find out that if there is any element which is lesser than this very first element, which we have by default taken it as a minimum element. So what I'm going to do is I'm going to check if minimum is greater than a of j. Now j value, as you all know, that j value is starting from 1, which means now my current j is here. I'm going to compare this and this. So when I'm comparing, minimum is still smallest. Okay. So then what is going to happen? Let me just change this value to 1. For our understanding. All right. So next, what is going to happen? Since minimum is not greater than a of j, I'm just going to once again increment the value of j. Now j is going to become 2. So when I'm comparing 2 and minimum, I know that 8 is still greater than 2. Hence minimum will remain 2 itself. And then I will increment the j value to 3. But when I'm coming over here, what is going to happen is 2 is not less than 1. 1 is less than 2. So if since we got an element which is lesser than 2, what I'm going to do is minimum is now going to be a of j, which means instead of minimum which was initially 2, now instead of that a of j. What is j value? J is 3. A of 3 is nothing but 1. Hence now minimum is going to become 1. All right. And location of that particular value is nothing but 3. Which is we are going to send the location 3. Now, why we are doing all this is basically in order to find out, like I told you, if this is my array, first I need to find out the minimum value. So that is what we did with the help of this entire minimum function is going to give us the minimum element. So this, as of now, we know the location of the minimum element. So whenever I get a location of the minimum element, next step is I need to exchange it with the very first element. Okay. So this location is now having the value of the minimum element. So interchange a of k and a of location. So a of k and a of location, we are going to interchange. What is the value of k initially? K is 0. So which means now I am going to interchange this. So temporary is equal to a of k is equal to location. This we have already discussed. So this is nothing but I am taking a temporary variable where I am storing the value of a of k. A of k is nothing but 2. Then at a of k, I am going to store the value of a of location, which is nothing but 1. And then whatever is there in the temporary, I am going to store it over here. Now this is how this exchange code works. So as you can see, after the exchange, now this is my new array. All right. So this is going to repeat. Repeat until what? Until we reach n minus 1. N minus 1 is nothing but until we reach, this value. Until we reach this. So once again, what I'm going to do, now that we have completed this k value, now we already know that 0th value is the correct value. Now I'm going to start from here. Hence, k value is going to be incremented to 1. Once again, I'm going to call you the minimum function. That is now only from 1 to 5 I'm going to call, which means now I need to find the minimum in this only. So once again, I will assign 9 as a minimum. I'll compare it with 8. I'll compare it with 2 and I'll compare it with 6. As we know that 2 is a minimum. Once again, this location will be sent to location value. And then now we are going to exchange it with a of k and a of location. Now remember k value is 1, which means that now I am going to exchange with a of k, which means I am going to exchange these two values. So when I complete the second iteration, my output array is going to be 1, 2, 8, 9, and 6. All right. So once again, now k value going to get incremented to 2. Now once again, I'm going to call the function minimum of 2 to n minus 1, which is 2, 3, and 4. Now I'm only focusing on this because I know that this is in a correct position, this is in a correct position. So call the minimum of a of k comma 0. So once again, my values are going to, now this I'm taking as a minimum. I'll compare 8 and 9, but 8 is still minimum. Next, I will compare 8 and 6, and 6 is the minimum value. Hence, we are going to send the position 4 as a location. Now, we are going to exchange a of k and a of 4, which is nothing but after the third iteration of the while loop, we will have 1, 2, 6, 9, and 8 in our array. Now, once again, we know that this is done, this is done, this is done. We will increment the k value to 3 and then we will send these 3 and 4. We are going to send this minimum into the minimum function, and we know that this is the minimum value. Initially, we will apply 9 to minimum. Then we'll find out that 9 is greater than 8. We are going to exchange this and then we will find the position as 4. We will get the location 4 here. We are going to exchange. So once we are done with that, finally, we will have 1, 2, 6, 8, and 9. This is our final array. Now, when it is going to terminate, this particular code will terminate when the k code will reach the n minus 1. That is, the moment it is going to reach, remember it is equal to n minus 1. The moment we reach here, when it comes to the fourth position, this after completion of this, it is immediately going to terminate as we do not have any more values to be compared next. And then we will get a output like this. All right. So selection sort is very simple. All we need to remember is the code for minimum. Minimum is also very simple. We are going to take first value as a minimum and compare and see if there is any other value which is less than this. The moment it is there, we are going to sending the location of that. Send the location to the selection sort. And selection sort is simply going to exchange the value of that position with the very first element. And this will repeat until we have covered all the values. All right. I hope this is clear. So this is a simple selection sort. Okay, so this example we have already seen. So just how we did. Initially, we will find out 1 and then we are going to exchange 1 with the 6. So 1 I have put here and 6 is being exchanged here. Next, what is going to happen? We are going to find out the minimum here, which is nothing but 2. 2 will be moved here and 3 is moved here. That is, which is nothing but we are going to swap these two. Next, in these 4, we know that 3 is the minimum. Hence, it will be swapped with 7 and 3. That is why 7 will reach here and 3 will come here. Next, among this, 6 is the smallest. Hence, 6 we are going to swap here and 7 will be sent here. That is why 6 is here. After that, once again, we will find the minimum here. It will be swapped here. Okay. And after that, once we reach the last element, we know that we are going to terminate the algorithm. So this is the very simple algorithm. So we are considering the time complexity analysis of a selection sort. For any, whether it is a best case or a worst case, it is always going to be order of n squared. This is because we are going to use two loops. As you can see, there is a loop inside the selection sort, and that selection sort in turn calls the minimum, and there also we are going to use a loop. So whether it is a worst case, best case, or a average case, it is always order of n square. And the space complexity of this particular algorithm will always remain as order of 1. That is constant, as it does not need any other additional arrays. Whatever the variable we are declaring, that itself will remain constant with this. Okay. So next, if you are going ahead and seeing advantages of the selection sort, it is simple. Okay, it is easy to understand and implement for beginners. In-place sort requires minimal additional memory. Since it is order of 1, we do not require any other additional memories, and fewer swap. Performs at most n swaps, which is efficient for an expensive writes, because how many number of elements you have, those many number of swaps it will have. So that is the advantage of selection sort. So if at all we are talking about the disadvantage, it's a poor performance on large data sets. If at all we have thousands and lakhs together elements, then it will show a poor performance. Always order of n square. Okay, regardless of the input, whatever value it is, whether it is a best case, worst case, it is always going to give you order of n square. So that is another disadvantage, not suitable for real-time applications because it takes so much of the time complexity is order of n square. And it is used for small arrays less than n elements when memory writes are costly and educational purposes. For basic sorting only, you can use that. Industry purposes and all, it is not suggested. This kind of a selection sort. All right. So that's all in today's session, students. Thank you for watching. Keep learning.